Hello students, I'm Zinnah. Assalamu alaikum, and I'm here today to solve our test paper. The test was on rates and equilibria, and let's start solving the question. Here you see the question. The first question 1A. When heated, hydrated crystals undergo the following reaction. The reaction is reversible. And here you see copper sulfate, blue crystal, and when heated, they decomposes to give water. And when water gone away, it forms white solid. The question is, what does the term reversible means? In language, this has a meaning, but in chemistry, in reaction, this has a specific term. This meaning is more specific, should be here. The reaction, certain reactions with both forward and backward rate or backward reaction. Okay, the reaction with both, including both forward and backward reactions, or that happens in both forward and backward direction. Anyhow, you can write that, or you may write in details to say that reactants produce products and products break down to give the reactants back simultaneously. That would be the answer. Describe an experiment to prove that the reaction is reversible. So the clue is given here in the equation. Use the equation to describe the experiment. Here, take the sample, blue sample, in a test tube. Okay, then you heat this. Then when heated, water will go off and you will have solid remains white solid. This is the forward reaction. And then for the backward reaction, add there some water. Add water again. And when water is added, then the backward reaction, these two will combine to form this again. The evidence is the crystal will again turn blue. So that's there. Okay. The hydrated crystals are heated, right? The hydrated crystals are heated in our test tube. Then the observation will be here: the blue solid, that's crystals, turns white. The observation is very important to score marks. Next is an amount, or few drop, you can write an amount of water is added to the white crystals again. And then what would happen? Again, observations. The white crystal turn blue again. So this is how we score marks. And for doing two things, heating and adding water, you will get here 2 marks. And for observation, you get another mark. If you miss the observation, then you miss the mark, 1 mark. Then the question B, consider. Question B is here. Let me check. Yes. Consider the formation of nitrogen monoxide. You see here, nitrogen monoxide is formed from what? Formed from nitrogen and oxygen gas. This is reversible too. And here is the forward reaction, endothermic. In order to obtain maximum yield, greater amount of yield of nitrogen monoxide at equilibrium, it's necessary to control the conditions very carefully. Yes, that's that. 3 conditions, that affect the rate, affect the position of equilibrium. These 3 other conditions. State what to do to know about forward and what do you know about forward and backward reaction. When backward rate, forward and backward rate, when the reaction reaches equilibrium or established. These two are equal. Okay, the answer is here forward forward rate equals backward rate of the reaction. Just this is the answer. These two are equal. And next question, state with a reason whether high or low temperature should be used to obtain greater yield. Greater yield means if equilibrium shifts to the right, then you may expect greater yield. And to control temperature, you should say the reaction, whether exo or endo. We already got the equation. Here's the equation, endothermic. Forward direction is endothermic. You know the theory, if temperature is increased, the equilibrium will shift to the right hand side here, because the right hand here endothermic. Okay, increasing temperature causes the position of equilibrium to shift to the right. This is high temperature. This should be high temperature. Okay, and why high? Because the forward reaction is endothermic, right? Endothermic. This will give a mark. Endothermic, important point, mark. As if the higher temperature will cause the position of the equilibrium to shift to the in short right hand side. This you cannot write an exam this way, but I just do it quickly. And here is another mark, and high temperature selection is one mark. And if you write here, backward reaction is exothermic, that is also okay. State with the reason what effect, if any, an increase in pressure would have on the equilibrium. You know, pressure is another thing that affects the position of equilibrium. How is that? This causes the position of equilibrium to shift to the side which has less gaseous molecules. Which side here has less gaseous molecules? No. Here are two more molecules or 2 moles. Here are 2 moles. So on both sides, you see same amount of gaseous substances. So this won't affect the position of equilibrium. No effect. So no effect for on changing pressure. Okay, as the number of moles of gases, okay, of gases are same on both sides. Okay, as reactant and products, this is mentioning this number of molecules or moles, anything you can write. And the position, this next point, this should be there. If you miss the point, as I said, the number of mole of the gases in the equation equal on both sides, the position of equilibrium, okay, equilibrium will not shift, okay, or you can write will be unaffected, will not shift to any direction. So for this, you should describe the mark. We move to the next question. State with the reason what effect, if any, of an increase in pressure would have on rate of reaction. Look, this is for rate. Remember, this is for rate. Here are the reactants. Reactants are gaseous, right? The reactants and gaseous. When they are gaseous, if they are there, this is compressor, suppose, the reaction mixers, reactants there. If you compress them, then volume will decrease, right? If the volume decrease, then concentration will increase. I mean, the particles will be closer. And when particles closer, there will be greater frequency of collision. Just it. So here 4 marks. 4 marks means you need to write many things. Rate increase. Okay, the rate will increase. Why is that? Reason. Okay, the volume of the gas mixer. This is the reactor mixer. reactor, volume of the gas mixer will, okay, decrease. There will compress. You can write there will compressed, same thing. So the particles will be closer, okay, closer to each other. Or you may write concentration will increase. Okay, concentration will increase, another mark, and then there will be greater frequency of collision. I got some of the students to write here energy, referring to energy, activation energy, or referring to successful collision. This won't have any mark because energy is related to heat or temperature. So these things we are talking about the pressure. So when you change pressure or particles are compressed, you are not giving them energy. So nothing here, no points here regarding activation energy or successful collision. Okay, are you clear? So here shouldn't be anything like energy or activation energy or successful collision. Next question, use the knowledge of the kinetic theory and collision between particles to explain the following statements or observation. See the observation when dilute hydrochloric acid is here, reacting with excess calcium carbonate. The reaction rate is slow as the reaction proceeds. The reaction slows down with proceeding in the reaction. This is for most of the reactions when here are the reacting particles, acid, and here is a solid, right? Here is solid that reacts. Gradually, rate decreases. Rate decreases, certainly decreases because particles are getting used up. Okay, but we write as here the concentration that we write in terms of concentration. The concentration of the acid, right? Of the acid decreases. Why? That decreases because there's used up. And oh, sorry, it's first thing unit. Okay, concentration of the particles decreases, and another thing, the solid gets smaller. Right, the solid gets smaller. The solid is big at the beginning of the reaction. So when the solid is big at the beginning of the reaction, then solid will have big surface. Big particle, big surface, and that's the particle, the sole particle, only particle there gets smaller. So its surface will be smaller. And both of them, for both of the reason, there's concentration and the solid. There will be a collision between these two particles and the solid. I mean, acid particles and the solid particles. And the frequency, okay? The frequency means how frequent they collide. Frequency of the collision. Collision will decrease. So this gives you another mark, will decrease. Okay, that's the answer. So here you shouldn't write anything regarding energy. How come this is related to energy? There's no relation between energy and this. And no activation energy, no successful collision to be written here. Just particles are more or less, just frequency of collision, not frequency of successful collision. Successful collision or energy we say only when temperature changes or when catalyst use. Catalyst also, when catalyst use, required energy, target energy is less, then there could be successful collision. And when hydrogen gas and oxygen gas are mixed at room temperature, there's no reaction. Why there's no reaction? What's the right answer for this? Why there is no reaction? This is because I got most of the students miss this point, because at room temperature the particles, reacting particles, right? The particles do not have activation energy. You should write the term properly, correctly. Activation, not only energy. The particles must have energy at any temperature, at room or any, but not the required energy. We call that activation energy. Then the next part says this will have a mark. Activation energy. This is clearly a mark. You missed, many of the students here lost this mark. Okay, if mixer is ignited, so ignition means, so ignition here gives the particles activation rate, right? Here you may not write activation energy. Instead of energy, you just write energy or kinetic energy, because already activation energy written. Kinetic energy or enough energy. Okay. Okay, and then if this there, then there will be there will be successful collision. Successful collision means a collision which breaks the bond. There will be frequent, as it says, the reaction will be fast. So I write frequent successful collision. I'll look carefully. In previous two questions, we didn't write anything about successful collision and about energy. We didn't write anything because there was nothing about here heating. That was about concentration. And this time we get about energy. So here's a powder. Magnesium powder immediately produces bright flash. I mean, when reaction, bright flash, when placed in Bunsen flame. But a piece, when this is not powder, means piece, lump, okay? Magnesium ribbons react slowly. So most of the students got correct marks for this question. This is okay. This is a piece of the, okay, the piece of the magnesium ribbon, okay, has what? Less surface area. This compared than the powder, right? And the powder. This is a mark here, and then you should write here frequency of collision. Frequency of collision is greater with the powder. Look carefully. I don't write anything here about energy or about successful collision. Why, you understand? I hope in previous discussion you got this. Now the next question is graphical. Our student carried out an experiment to investigate the rate of reaction between magnesium and excess of sulfuric acid, hydrochloric acid. The total volume of hydrogen gas produced at room temperature was measured every 30 seconds for 4 minutes. You understand the language, what it says? Here is an experiment container. The reaction is here, and gas being collected in a gas syringe. The volume of gas, this is the volume of gas, will increase gradually. When time is 0, then here is no volume because the reaction has not started. And here is 30. After 30 seconds, you get a volume. After 60 seconds, you get the volume. This is cumulative volume, total volume. Now the question here, drawing graph. Okay, drawing graph. And We need to place they should be together. Okay, they should be together. And in this side, you got time. Look carefully how to plot them in the graph. And this is volume. You first need to estimate the value for every of the unit. This is a single unit in the graph. Here are 10 units. 10 units together is 60. So every unit here, value of every unit here is 6 seconds. You understand? If you divide 60 with 10, you get here 6. 6, here is 6, here is 12, like this. And on this axis, you get your 30, 30 given for 10. And if you divide this with 10, what do you get? 3. 3 here. So 3 means this is 3, and this is another 3, this is another 3. This is how they work. So now let's see how to plot. First, it says 0, 0, and second, it says 30, 38. 30 and 38. 0, 0 means, and I am going to erase this. Here, 0, 0, 0, both are 0 to be here. Okay, that should be drawn with cross all the time. And 30. 30 is between 60, 0 and 60, it must be middle, right? Middle. And this given 30 what? 38. 38. Remember, this is 30, and every unit is 3. So here is 33, here is 30, what? 36, here is 39. Yes, 39, we can plot this in 39, and little short to 39, just short to 39, because 38 is not properly given here. So this is the first reading. Then 60, 65. 60 is clearly here, and 65, here is 60, right? And this is what? 63. And this will be 66. We may consider this little short to 66. Yes, this is done. And next value given here 90 and 86. Now volume decreasing. 90 is, this is the 90 between 60 and 120. Here it says 86. No, this is 90, right? And if one unit gone, then 3 gone from 90. Then this will be 87. And our value says 86. 86 means just close to 87. So this gives here. Okay. Next one, it says 120 and 102. 120 is here. And where is 102? Here's 90. And what's that? The middle? Middle is 30 and then 45, 105 here, right? Between these two, 105. 115 or 105, sorry, 105. Because 15. This to this 15, this to 15. So here is 105. What is there? 102. Just one less point. Here, one less point, approximately here. Okay, 102 we got there. Then 150, 111. 150, where is 150? 150? Yes, 150 is at the middle. Yes, here is 150 and 111. 111 means here is 105, then 3, 108, then 311. Okay, this is there, 111. This should be 111. Where is that I draw? 111. If you come down, here is 120, then 3 gone, 3 gone. If 6 gone and 9 gone. 3, 3, 3, 3, 9 gone from 120, then become 111. It's okay. Then next reading for 180 and 117. Where is 180? 117. One just below this, because it's 120 and subtract 3. No, every point is 3. 3 will be here. So just here is the reading. we get here 210 and 120, 210. 210 should be here at the middle, right? 210, 30, yes, 210. And what's the other thing? 120. 120 is here, 120. This should be here. And the next reading is same at 240. 240 and next reading. Students, I hope you understand here clearly how to draw, how to plot them. First thing is this. You need to estimate the value for every unit, then you put the value. So here should be a best fit line. Here should be a best fit. This is gonna do. This is not okay. First, before this is wrong here. When you draw this in pencil, that would be easier, right? This little problem here, you just consider straight line. Okay, somewhat is okay. Then we move to the next question. How long from the start did it take for half of the magnesium to react? So you're working on the graph. This is talking about half-life. When the reaction is complete, all the magnesium reacted. When all the magnesium has reacted, you got the result, 120 cm³ volume of the gas. If half of the magnesium, that means that when this produced 60 cm³. Here 60 means half-life. And move to the curve. Here this gives and straight down. Straight down, here is just one short of this, 6 short of 60. This is 54, right? 54. This should be shown. The value, correct value, 1 mark, and shown in graph is 1 mark. On the same axis, sketch graph you would obtain if the experiment was repeated using hydrochloric acid, higher concentration, same mass. So here are 2 points. When same mass will give same volume, right? When higher concentration will give you greater rate. So 2 marks. One is to maintain same volume. Another is to give here greater rate. Same volume means will give this height, and greater rate means will be steeper. Okay, this is here. Remember, this line should be straight line beforehand, before this point, when the previous reaction stopped. Clear? This is okay. And the next question. Use the total volume of the gas produced to calculate mass of magnesium used in the experiment. Here, molar volume given, molar mass given, mole of the gas. In the reaction, we got the volume 120. This is volume by molar volume. Okay, molar volume is molar volume like this. The volume we got that 120 divided by 24,000. This gives the molar volume. What do you get there? Calculate. 120 divide 2400 and 0. I get here 0.005 mole. Okay, this is the mole, and mole of magnesium reacted. This is same because in the equation the mole ratio given there same. Okay, just write same. If you see the equation, you will see their mole ratio is same. See carefully. Here the magnesium and here's the hydrogen gas. These two are being compared. They're equal mole. So when equal mole, they are also equal. You can mark. And then mass of magnesium. So mole into molar mass. This is mole into molar mass. Mole is already there. 0.005 multiplied with 24 given. 24 given. If this is multiplied with 24, what should we get? 0.12 gram. So this sharply 3 calculation, 3 marks. These are from mole chapter, right? What is a catalyst? And to define catalyst, you should write first chemical substance. These are not heat, right? Chemical substances with speed up rate of reaction. And then the main point is without being used up. Don't write without reacting. They react, actually react, but not used up. Marks you are getting here is 1 and here is 1. Okay, these 2 marks you will get here. Explain how a catalyst increases rate of reaction. How is this? This does because this easier route, the reaction occurs easier route is the route of the reaction. This is easier alternative I can write. Alternative route of the reaction. Okay, so this scores some marks and less activation energy. Less activation energy. Another marks. Excuse me, some of the students has written here that activation energy decreases. This is not true. Don't write activation energy decreases. You can write activation energy less, but not decreases, because this is totally a different route. So if the same route were there with less energy, then you could have said that decreases, but that's not the case. Okay, now draw a profile. Profile means you should show the activation energy, and reactants are this, products are this, and delays are this. All the informations here need to be shown here. This is exothermic. Exothermic means reactants should be at higher level. Here you should write this too. If you just write reactants, you will lose mark. You shouldn't write just reactant. N2 and 3 is 2. Right? These 2 properly should be written there. You may not write a state symbol or things. And the products, here's a product. Products should also be written correctly. You shouldn't write the just product. Okay? Just product is not there. To write the N is 3. Just for marks. This is there, and this value to be placed there. Where that del is? Difference is there. Here is the difference. This is minus 93 kilojoule per mole. The arrow sign should be properly placed. Must be between this and this line. Must be between these 2 lines. Okay, I got some mistakes, so I emphasize here. And here it says that profile. This I have drawn is not reaction profile. This is so far is called simple enthalpy level diagram. If I add there reaction route and I show here this height to be activation energy, okay, activation energy, then this is here what profile. So let's score 2 marks. Draw another route. The question says draw another route. Okay, another route. Draw another route here for a reaction if catalyst is used. If catalyst is used, then this will be like this. This gives a different route. So why we don't say activation energy decreases? Decreases when if this line or this route changes, then this could be decreases. Actually, this route is different. If you follow this route, you will need same activation energy. And when you are following this route, then this is the activation energy. So you don't say activation energy decreases. You should say activation energy less, or as reaction happens at lower activation energy. So these are there. Thank you very much. And we'd get marks. And sometimes you may write here another point that more molecules have activation energy. If marks are more molecules have activation energy. Okay, activation and energy. if you have more marks to write. Okay, thank you very much. We're finished. We're finished. I hope this has made your concept very clear. And the mistakes you got, you should correct them and send me again. Thank you. So.